Technology is advancing faster than ever, and 2026 is emerging as a year filled with groundbreaking innovations that could reshape the way we live, work, travel, communicate, and interact with intelligent machines. From powerful artificial intelligence and next-generation robotics to quantum computing, clean energy, autonomous transportation, advanced medical solutions, and futuristic consumer technology, a new wave of breakthroughs is moving from concept to reality. In this video, we're taking a closer look at 17 exciting technology trends that could define 2026 and have a lasting impact on the years ahead. Many of these technologies are already being developed, tested, and introduced into real-world applications, offering a glimpse into what the future may look like. So, let's explore the innovations pushing the limits of what is possible and discover the technologies that could shape the world of tomorrow. Number 17. The NVIDIA Vera Rubin platform represents a major leap in AI computing, designed to power the next generation of advanced reasoning, agentic AI, scientific computing, and massive-scale data center workloads. At its core, the platform combines NVIDIA Rubin GPUs with the new Vera CPUs and a complete networking and infrastructure stack, creating an integrated AI supercomputer rather than simply another generation of graphics processors. The Rubin GPU is built specifically for demanding AI workloads, featuring HBM4 memory, a third-generation transformer engine, advanced adaptive compression, and up to 50 petaflops of NVFP4 inference performance on a single GPU. The Vera CPU complements the GPU by handling data movement, orchestration, and the increasingly complex workloads created by AI agents, using 88 custom NVIDIA Olympus cores and high-speed NVLink C2C connectivity to provide extremely fast communication between CPU and GPU resources. Number 16. Samsung Intelligent Eyewear represents a new generation of wearable technology designed to blend artificial intelligence, smart functionality, and everyday convenience into a lightweight pair of glasses. Unlike traditional eyewear, intelligent glasses are designed to become an always-available digital assistant, giving users access to useful information without constantly reaching for a smartphone. Samsung's approach to intelligent eyewear focuses on integrating AI into a natural wearable form, potentially combining cameras, microphones, speakers, sensors, wireless connectivity. Number 15. Commonwealth Spark is an ambitious fusion energy technology concept designed to demonstrate that practical fusion power can be achieved using high-temperature superconducting magnets and a compact tokamak architecture. Developed by Commonwealth Fusion Systems, Spark is designed around powerful high-temperature superconducting magnets that can generate an extremely strong magnetic field, allowing the reactor to confine and control the superheated plasma needed for fusion. Unlike conventional tokamaks that require much larger structures to achieve similar magnetic confinement, Spark aims to demonstrate that stronger magnetic fields can enable a significantly smaller and more compact fusion device while still reaching the extreme conditions required for fusion reactions. At the heart of the system is a donut-shaped vacuum chamber where hydrogen isotopes are heated to extraordinary temperatures, turning the fuel into plasma. Powerful magnetic fields then hold this plasma away from the reactor walls, creating the conditions necessary for atomic nuclei to fuse and release enormous amounts of energy. Number 14. Climeworks Direct Air Capture is an advanced carbon removal technology designed to extract carbon dioxide directly from the atmosphere and permanently store it, offering a potential solution for reducing one of the most difficult greenhouse gases to remove once it has entered the air. The technology works by using large-scale machines equipped with specialized filter materials that selectively capture carbon dioxide from ambient air as it passes through the system. Fans draw surrounding air into the collectors, where the carbon dioxide binds to the filter material while other components of the air continue through the system. Once the filter becomes saturated, the collector is closed and subjected to controlled heat and vacuum conditions, which release the concentrated carbon dioxide and regenerate the filter so it can be used again. The captured CO2 can then be compressed and transported for permanent geological storage, preventing it from returning to the atmosphere. Number 13. Synchron BCI is a brain-computer interface technology designed to create a direct communication pathway between the human brain and digital devices, with the goal of allowing people to interact with technology using neural signals rather than conventional physical controls. At the center of the system is a small implantable device called the stentrode, which is designed to be delivered through the blood vessels rather than requiring traditional open brain surgery. The device is positioned in a blood vessel near the motor cortex, where it can detect electrical signals associated with a person's intended movements. These neural signals are then transmitted to an external device, where specialized software and artificial intelligence can translate them into digital commands. This approach could allow a person to control a computer cursor, select letters, communicate, send messages, or interact with other digital interfaces simply by thinking about the desired action. Number 12. Astribot Lumo 2 represents the emerging generation of intelligent humanoid robotics, combining advanced artificial intelligence, sophisticated motion control, computer vision, and human-like physical interaction into a single robotic platform. Designed around the idea of making robots more capable in real-world environments, Lumo 2 is aimed at performing useful tasks that traditionally require human movement, coordination, and decision-making. One of the most important technologies behind a robot of this type is its AI control system, which allows the machine to understand its surroundings, interpret instructions, plan actions, and continuously adjust its movements based on what is happening around it. Instead of simply following a fixed sequence of program commands, an intelligent humanoid robot can use cameras and other sensors to recognize objects, estimate distances, identify obstacles, and determine how to interact with different environments. Number 11. The Xtool O1 Omni Printer represents a new generation of multifunctional digital fabrication technology, bringing several creative manufacturing capabilities together into a single compact machine. Instead of relying on separate devices for different projects, the O1 is designed to provide a versatile workspace for makers, designers, small businesses, hobbyists, and creators who want to transform digital designs into physical products. One of its key advantages is its ability to work across different materials and applications, allowing users to create personalized signs, decorative objects, accessories, gifts, prototypes, artwork, and other customized products. The system combines advanced motion control, precision positioning, intelligent software, and automated workflows to make the fabrication process easier and more accessible, even for users who may not have extensive technical experience. Its enclosed working environment is designed to provide a more controlled production space, while integrated cameras and sensors can help with positioning, alignment, material recognition, and project setup. This type of visual intelligence is particularly useful because it can reduce manual measurements and make it easier to place designs accurately on different workpieces. Number 10. Code represents an emerging approach to wearable technology that focuses on making digital information more accessible through a small, discrete device designed to work naturally with the user throughout the day. Rather than depending entirely on a traditional smartphone screen, technology like Code is built around the idea of delivering useful information, communication, and intelligent assistance in a more compact and convenient form. Its potential functionality can include voice-based interaction, wireless connectivity, notifications, hands-free communication, and integration with AI-powered services, allowing users to access digital features without constantly taking out their phones. A key advantage of this type of wearable is its portability, as a small device can remain attached to clothing or personal accessories while providing quick access to information whenever it is needed. With microphones and intelligent processing, it can potentially understand spoken commands and convert natural language into useful actions, while wireless connectivity can allow it to communicate with a smartphone or cloud-based services. Number 9. IDM Power Alpha 50 is an advanced electrolyzer technology designed to produce green hydrogen by using electricity to split water into hydrogen and oxygen, providing an important pathway toward cleaner industrial energy and lower carbon fuel production. Developed around proton exchange membrane, or PEM, electrolysis, the Alpha 50 is designed to convert renewable electricity into hydrogen without requiring fossil fuels as the primary energy source. The system uses an electrolyzer stack containing specialized membranes and electrodes, where electrical energy drives the water-splitting reaction. One of its major advantages is its ability to respond quickly to changes in electrical power, making PEM technology particularly suitable for renewable energy sources such as solar and wind, where electricity generation can fluctuate throughout the day. The Alpha 50 is designed as a modular system, allowing hydrogen production capacity to be deployed in a compact and scalable configuration rather than requiring a massive centralized facility from the beginning. Its technology includes advanced water management, power electronics, gas separation, cooling, monitoring, and control systems that work together to maintain efficient and reliable hydrogen production. Number 8. Flint Paper Battery represents an emerging approach to energy storage that explores how battery technology can become thinner, lighter, more flexible, and easier to integrate into everyday products. Instead of relying entirely on the rigid shapes associated with conventional batteries, paper-based battery concepts use thin layers of conductive and electrochemically active materials that can be incorporated into a lightweight sheet-like structure. This type of technology is particularly interesting for applications where traditional batteries are too bulky, such as smart packaging, disposable sensors, wearable electronics, medical monitoring devices, identification systems, environmental sensors, and other low-power connected products. A major advantage of a paper battery is its extremely thin and lightweight form factor, allowing energy storage to become part of products that previously had no practical way to include a conventional power source. Number 7. Ocean Infinity's Armada represents a new generation of autonomous maritime technology, combining advanced robotics, artificial intelligence, satellite communications, remote operations, and large uncrewed surface vessels to transform the way work is performed at sea. Instead of depending entirely on large crews onboard conventional ships, the Armada concept is built around remotely operated and increasingly autonomous vessels that can travel long distances, collect information, inspect underwater infrastructure, map the ocean, and support complex offshore operations. One of its most important features is the use of autonomous navigation, allowing vessels to plan routes, monitor their surroundings, avoid obstacles, and adjust their course with limited direct human intervention. Advanced sensors, cameras, radar, navigation systems, and artificial intelligence work together to provide the vessel with a detailed understanding of its environment, helping it operate safely in challenging maritime conditions. Number 6. Quantinuum Helios represents a major advancement in quantum computing, designed to push trapped ion technology toward increasingly powerful, accurate, and practical quantum systems. At the heart of Helios is a processor architecture that uses trapped ions as qubits, with individual ions held in place using electromagnetic fields and controlled with highly precise laser-based operations. Unlike conventional computers that process information using bits represented as zeros or ones, Number 5. Tron 2 Autonomous Mobile Manipulation represents an emerging class of intelligent robotic systems designed to combine autonomous navigation with precise physical manipulation, allowing a robot to move through real-world environments while independently interacting with objects around it. Unlike traditional industrial robots that typically remain fixed in one location, a mobile manipulation platform can travel between work areas, identify objects, plan movements, and use robotic arms to perform physical tasks. The core technology combines artificial intelligence, computer vision, advanced sensors, mobile locomotion, robotic arms, and sophisticated motion control software into a single system. Cameras and depth sensors can continuously scan the environment, helping the robot recognize objects, estimate distances, detect obstacles, and understand the layout of a workspace. Artificial intelligence can then use this information to determine what needs to be done and generate a sequence of actions, while motion planning algorithms calculate how the robot should move its body, arms, and end effectors to complete the task safely and efficiently. Number 4. Italdesign Elef Sonic represents an innovative approach to next-generation electric vehicle technology, combining advanced in-wheel motor engineering with futuristic vehicle design to explore how electric mobility can become more efficient, flexible, and intelligent. Developed through the collaboration of Italdesign and Elef, the Sonic concept highlights the potential of integrating electric drive technology directly into a vehicle's wheels, reducing the need for traditional centralized motors, transmissions, and other drivetrain components. In-wheel motors place the electric propulsion system inside or directly around the wheel assembly, allowing each wheel to receive its own independently controlled source of torque. This architecture can provide highly precise control over acceleration, traction, and vehicle stability because software can continuously adjust the torque delivered to individual wheels based on road conditions and driving requirements. One of the most significant advantages of this approach is packaging efficiency. Number 3. LG UltraView Windshield Display represents a new generation of automotive display technology designed to transform the vehicle windshield into an intelligent information surface while helping drivers keep their attention focused on the road. The concept builds on advanced transparent display technology, allowing digital information to appear within the driver's field of vision without requiring a traditional dashboard screen or smartphone. Instead of looking down at a separate display, drivers can potentially see important information such as navigation directions, vehicle status, warnings, speed information, and other contextual data directly in front of them. One of the key technologies behind this type of system is transparent display engineering, which allows visual content to be overlaid onto the real-world environment while maintaining visibility through the glass. This creates a form of augmented reality in which digital information and the physical road environment can appear together. Advanced optical systems are essential because the display must remain bright and readable under different lighting conditions, including direct sunlight, nighttime driving, rain, and changing weather. Number 2. Lincoln Adaptive Cruise Control is an advanced driver assistance technology designed to make highway and long-distance driving more comfortable by automatically adjusting a vehicle's speed according to surrounding traffic. Unlike conventional cruise control, which maintains a fixed speed regardless of vehicles ahead, adaptive cruise control uses sensors and intelligent control systems to monitor the road and maintain a selected following distance from traffic. The system typically combines radar, cameras, and vehicle control software to detect vehicles traveling in the same direction and continuously calculate their distance, speed, and relative movement. When the road ahead is clear, the vehicle can maintain the driver's selected cruising speed, but when slower traffic is detected, the system can automatically reduce the vehicle's speed to maintain an appropriate gap. Once the traffic clears, the system can accelerate again toward the preset speed, creating a smoother and less demanding driving experience. One of the key technologies behind adaptive cruise control is real-time sensor processing, which allows the vehicle to continuously evaluate changing traffic conditions rather than relying on a single measurement. Number 1 ABB Robotics POWA CRB 1910 represents a new generation of collaborative robotic technology designed to bring flexible automation into industrial environments where robots need to work efficiently while operating closer to people. As a collaborative robot, or cobot, the CRB 1910 is designed around the idea that robotic systems can support human workers rather than being completely separated from them by traditional safety barriers. Its technology combines precision motion control, intelligent sensing, advanced software, and a compact robotic design to perform repetitive, physically demanding, or highly consistent tasks with accuracy. One of the key advantages of a collaborative robotic platform is flexibility, allowing the robot to be deployed across different applications and potentially repositioned as production requirements change. The CRB 1910 can be used for tasks such as machine tending, assembly, material handling, inspection, packaging, and other repetitive industrial operations where consistent movement and precision are important.